Well, in this video, we're just going to do one example that has 4 parts to it, and we'll use some of the terms that we learned in a previous video. So here's a mapping. Doesn't say whether it's a linear transformation, 1 to 1 and on 2 or not, but that's not important. We're just going to apply some of the principles from the previous video. Now remember what this means. This means that f of the ordered pair xy is going to give us a new ordered pair x prime, y prime, and we're told what x prime and y prime are. It's going to be x plus y plus 4. That's the new x value, the x prime value. And the future, or the new y prime, is going to be x minus y minus 6. So this is basically the function or the mapping that we are working with. So to start off, it just says, find the images of these 3 ordered pairs A, B, and C under this function f. So this is pretty straightforward. Notice that I'll start way over to the left. F of A means f of, what's A? 3, 1. So 3 and 1 are my x and y. So I need to just compute what the x prime, y prime are from that. So f of A is f of 3, 1, which is going to be this ordered pair, xy. And we're going to use this formula here, right? X plus y plus 4. So my 3 and 1 are the x and the y. So x plus y plus 4 will be 3 plus 1 plus 4. And then to get the new y prime, the y prime value, I'll have to do x minus y minus 6. So it's going to be 3 minus 1 minus 6. Just substitute in like that. And let's see what we get here. 8, and then we'll get 3 minus 1 is 2 minus 6 is negative 4. 8, negative 4. So this mapping f takes the ordered pair 3, 1 and maps it over to 8, negative 4. Let's repeat for B and for C. F of B, that says B, although it doesn't look like it. F of B, B is 4, 6. So that's my x and my y, and I need to come up with a new x prime, y prime using this formula here, or using this right here. So it's going to be x plus y plus 4. So it's going to be 4 plus 6 plus 4. And then on the next one, it's going to be x minus y minus 6. This is x and y. 4 minus 6 minus 6. 4 minus 6 minus 6. So let's simplify that. We'd get 10, 14, comma, 4 minus, that's like 4 minus 12 would be negative 8. So this mapping takes the ordered pair 4, 6 into 14, negative 8. In f of C, C is the point 5, 11. F of 5, 11. So the x and y are 5, 11. All right, to get the x prime, remember this is the x prime and y prime up here. So to get their images, the x prime image would be 5 plus 11 plus 4. And the y image, the image of y, would be x minus y minus 6. 5 minus 11 minus 6. So what do we get here? 16, 20. And then 5 minus 11 is negative 6. Minus 6 is negative 12. Okay, so we computed images of 3 random points. Now we're going to go the opposite direction. We're going to find the pre-image of the point 2, 2. So once again, what that means is 2, 2, we'll say, is about here. We need to find the point in the plane that maps to 2.2. That gives us the pre-image. Here's the image of the point, and then we need to find the pre-image of 2, 2. So that is, we have to find a point P such that f of P equals D, 2.2, or 2, 2. So here's the hint. Since x prime is 2 and y prime is 2, set up and solve these two equations for x and solve them for y. So that shouldn't be too difficult. So let me just write a note. We need an ordered pair xy such that these two equations are true, such that x prime equals x plus y plus 4 and y prime equals x minus y minus 6. I just copied these two equations up here. Okay, well, notice what will happen. Let's see. I want to solve these for x and y. Okay, so I'm going to do a substitution here because x prime is 2. So let's just write 2 equals x plus y plus 4. And y prime is 2, so write and 2 equals x minus y minus 6. So we're solving that system of two equations, which of course can be simplified. Let's write this like, let's see, if I subtract 4 from both sides, I would get x plus y equals negative 2. So x plus y equals negative 2. That's this equation right here. And if I simplify this one, I would get x minus y, add 6, to get 8 over here. I would get x minus y equals 8. All I have to do is solve that system of two equations for x and y. So what I'm going to do here is take this equation, and notice I have a positive y and a negative y here, so if I add the equations together, the y will disappear. So here's my first equation, here's my second equation. I'll write the second equation right underneath, make it easy. X minus y equals 8. We add these two equations together, I get a 6. That cancels out, and I get 2x equals 6. So that tells me that x equals 3. Okay, well, if x equals 3, I can use either one of the equations to find out what y is. If x is a 3, I could go 3 minus y equals 8. And what does that mean? If I add 8, subtract that, I think I'd get a negative 5. Y equals negative 5. So the ordered pair is 3, negative 5. So we could say that f of 3, negative 5 is equal to 2, 2. All right, so we found the pre-image of 2, 2. We have the point that maps to 2, 2 is 3, negative 5. Maybe I'll put a circle around that. Now let's find the inverse transformation, f inverse. So what we'll do is we'll solve the system up here for x and y instead of x prime and y prime. Okay, so let me write them down again. I'm going to write x prime equals x plus y plus 4. And the second one is y prime equals x minus y minus 6. Okay, well, I wrote one above the other because what happens if I want to solve this for x in terms of x prime and y prime, I want y to disappear, I could just add those two equations together similar to what we did in part 2. So I will add the equations to get what happens if we add these two equations together right here. Well, on the left, I'm going to get x prime plus y prime. And then when we add these two together, the y's are going to cancel out. I'm going to get 2x minus 2. Okay. All right, so now I'm going to get another equation. And let's do something similar to, let's see, maybe we didn't do this upstairs, but now let's subtract the two equations and see what we get. Subtract the equations. And why am I subtracting the equations? Because I'll have an x minus x, and the x will disappear. Okay? So if we do the subtraction, I'm going to get x prime minus y prime equals x minus x is 0. Y minus negative y, that's going to give me 2y. And then 4 minus negative 6 is 4 plus 6, which is a 10. So let's see, plus 10. Okay, so now notice, I can solve both of these equations. I can solve the top one for x in terms of x prime and y prime. I can solve the bottom one for y in terms of x prime and y prime. And that's exactly what we wanted to do. So let's see. Maybe I'll call that equation 1 and that equation 2 because I'm going to go down here. I'm just going to say from 1, we get x is equal to what? Let me do it all in one step. I'm going to add 2 to both sides to get rid of that minus 2, and then I'm going to divide by 2. So x prime plus y prime plus 2, adding the 2 to both sides to get x by itself, and then dividing by 2. Okay, we're done with that. We've solved x. That's equal to x. We've solved for x, and on the next one, number 2, we'll solve for y, which means I'm going to subtract 10 and then divide by 2. X prime minus y prime minus 10 all over 2, and that's y. So that's going to be our inverse function. So we could write it like this. From all of this, we would get f inverse is the function x equals y equals, and then we're going to have x prime and y prime functions on the right. Exactly what we have here. Maybe I'll rewrite it as 1/2 of x prime plus y prime plus 2. And down here, I'll write it as 1/2 of x prime minus y prime minus 10. So that's the inverse function. We started with a function that computes x prime and y prime in terms of x and y. The inverse function, we have x prime and y prime and we need to compute x and y, the pre-image. All right, finally, find the fixed points if there are any. Remember what fixed point means? It would be we need f of xy equal to xy. an ordered pair, if there is one, that doesn't change under this mapping. Okay, so we would need, in other words, we'd need x prime to be x and y prime to be y. No change whatsoever. So we need x equal to x plus y plus 4, and we need y equal to x minus y minus 6. Now we're going to solve this system of two equations, and we're going to find if there's an ordered pair, if there is a solution. So again, all we did is we took the original up here, and if we need f of xy to equal xy, that means that x has to be x prime and y has to be y prime. F of xy equals xy, which is equal to this. So let's see if we can make that work. Solve these. Okay. Solve. Well, notice we can simplify first. What is this? If we subtract x from both sides, this is going to be really easy. The first equation, subtract x from both sides, gives us what? 0 equals y plus 4, so y equals negative 4. So equation 1 tells us that y is equal to negative 4. So we're halfway done. Now I need to solve for x. And I guess we'll simplify here again. What do we get from equation number 2? We would get x. Let's see, maybe I'll get y by itself. Add y to both sides. 2y. Actually, we already know. Let me solve it for x. Solve this for x, because I already know what y is. So if I want x by itself, I have to add y to the other side, 2y, and I add 6 to the other side as well. And now we know that y is negative 4, so x is equal to 2 times negative 4 plus 6. That's going to be a negative 8 plus 6 is negative 2. So that's our fixed point. Fixed point is negative 2, negative 4. Let's verify that. If I plug in a negative 2 and a negative 4 here, I should get out a negative 2 and a negative 4. What is negative 2 plus negative 4 plus 4? Well, negative 4 plus 4 is 0, so I just get negative 2. So negative 2 stays the same. And then negative 2 minus negative 4 minus 6, we want that to give us a negative 4. Negative 2 plus 4, that's 2. 2 minus 6 is negative 4. Yes, so indeed, f of negative 2, negative 4 is equal to negative 2, negative 4. So that is the only fixed point in this mapping.